In this video, we will calculate a complete Banzhaf power distribution. And we'll return to the example that we did when I first introduced the term coalition in notation, the example in which we had 4 players with weights 7, 5, 4, and 3, where the quota was set to be a simple majority. And if you recall, we actually already found all the winning coalitions, and since that's step 1, we've already kind of done part of the work for the Banzhaf power distribution. So let's just return back to that process, which, again, we could start with the group of all 4, which is winning. I believe we found 8 of them. Then when coming to 3-player coalitions, I believe they were all winning. There was 754, 753, 743, and 543. And remember, you can find each of those by removing 1 player at a time. And I believe there were 3 2-player winning coalitions. I think all of the groups with 7 were winning, but if they did not have 7, they wouldn't win with only using 2 players. And yeah, that's 8, so I think that's consistent with what we got before. So that's step 1. Step 2 says to, within each winning coalition, determine the critical player. So kind of like we did in the last video, we want to figure out who should be underlined and who should not be underlined. And if you keep your coalition somewhat organized, it'll actually make it a little bit easier as we're going through it to determine who's critical. Excuse me, I had to hiccup there for a second. Sorry if I'm a little hyper in this video. I just had some lunch and some coffee, and now I'm kind of wired. So I will try my best not to speak too fast, which I will sometimes do, but not on purpose. Okay, so let's start with the Grand Coalition. In this case, I believe that nobody is critical, right? And so if I'm thinking about removing people one at a time, if I remove player 1, 7, 4, and 3, they still have enough votes to make the quota. And there's another way of determining it. Notice that since I have all of the winning coalitions, I can kind of tell that 7's not important, because if I remove 7, they're still winning. And same goes for 5, 4, and 3, right? Because each of those coalitions where 1 player was removed are all winning. So none of these people individually are critical in the larger coalition. That's pretty typical in the Grand Coalition. Most of the time, nobody's critical. But again, you got to double check just to make sure. And looking at the small coalitions, actually everybody's critical to these because no one person by themselves could win, right? But basically both of those 2 votes were important to make it to 10. Removing any one of them will obviously make it a losing coalition. So generally the small coalitions are easy, the large ones are easy because they're usually all or nothing. But in the middle there's a little bit more variation. So let's check with 7, 5, and 4. Notice that in these coalitions 7 is critical because if 7 were removed, that would only leave us with 9. But if either 5 or 4 were eliminated, and again always only one at a time, it wouldn't matter because 7 and 5 or 7 and 4, those are both winning coalitions. So in this coalition, only 7 is critical, neither 5 nor 4, since if we remove either 5 or 4, the weight would still be either 11 or 12, which would pass the quota. And again, my focus for all of these number calculations is always on the quota, and that's, why 10 is kind of what I want to know. Is it 10? Is it greater than 10 or greater than or equal to 10, or is it less than 10? And in the case of removing 7, it would be less than 10, but the others, greater or equal. And actually, I believe it's exactly the same in the next 2 as well, because if 7 were removed, 5 and 3 or 4 and 3 would definitely come up short of 10. But if it's either 5 or 3 being removed, 7 plus any of the other ones is going to have enough votes to make it to the quota. So again, you can use the complete list to help. And usually one of your homework questions will it's sort of like a harder question, but it'll ask you to figure out who's critical without knowing the numbers. And basically, it's kind of using the strategy where you want to know, you can figure out who's critical by seeing if they're removed, is it still winning or not. But moving down to the last 3-player coalition, 5, 4, 3, let's check these one at a time because I think they're all critical if I remember correctly. But notice that if I remove player 1, yes, player 1 is, sorry, that's player 2, not player 1. But the first player in this coalition, if you know what I mean. But the player with 5 votes is critical because 4 and 3 definitely cannot make 10. So 4 is also critical, right? Because if I remove 4, that would only be 8, not enough. And 3 is also critical barely, because if 3 is removed, 5 and 4 fall short. So kind of the difference in these coalitions, kind of stepping back from the procedure and just talking about the concept, really all 3 of these people are needed in this group to make it to the quota. And basically they're all equally important. But in these groups, only the 7 is the really only important person. Technically, it doesn't come down to like a dictatorship though, because um, 7 still needs someone else to come on board. It just doesn't really matter who it is. So those people don't have individual criticality, and that's why they're not, gauged as important by the Banzhaf power method. So that concludes step 2, finding all the critical players. Then the final 3 steps are the easiest part. Basically, it's a matter of figuring out how many times people were underlined. So player 1 was underlined 1, 2, 3, 4, 5, 6, and that we use B1 to stand for the critical count for player 1. Player 2 is the player with 5 votes. They were critical once, twice, so B2 is going to be 2. Player 3 was critical once, twice. Player with 4 votes, which we'll do as B sub 3. And B sub 4 would be correspondent to player 4, the player with 4 votes, sorry, with 3 votes. And this is another confusing thing, is player 3 has 4 votes, while player 4 has 3 votes. So if you're dyslexic, you got to be very careful and make sure you're dealing with the correct numbers, which is a little frustrating sometimes. But the player with 3 votes was also critical twice, there and there. So basically, figure out how many times everybody was underlined. In this case, it comes out to 6, 2, 2, 2, which would be our each of our critical counts. Then what it says to do is add them all up for T. So basically, add those all up. That comes out to be 12 total underlined players. So we got the total critical count of 12, and each player's individual ratio from part to whole would give us our Banzhaf power index for each person. And the book uses beta 1, beta 2, and beta 3, and beta 4 for those quantities, just as it's kind of the Greek version of B, and the book starts to run out of letters to use for things, so that's that's kind of what I surmise is why they're using beta for the Banzhaf power indices. And anyways, from here, we can see that we get an answer as fractions. What I would generally do, well, your homework will often ask you to reduce those fractions. If fractions aren't your thing, you can always use a calculator, but just as a very quick recap here, we can divide out the common factor of 6, which would leave us with 1/2. And with 1/12, we could divide out the common factor of 2, which would leave us with 1/6. Or your calculator can also do fractions if you're not too confident in your ability. If you type in a fraction, this is a feature that a lot of people aren't aware exists in most calculators. If you then go into the math menu, the actually very first button right there will convert an answer into a fraction, and it'll even reduce it for you as well. So you can take that fraction and put it in reduced terms or simplest terms, or we can write it as a decimal or a percentage. And typically I prefer percentages because, like as we saw with the European Union, it had them listed as percentages. Most people kind of understand percentages, and not everybody understands fractions as well. So in this case, it would be 50%, of course, which is equal to 1/2. But you can always take your decimal value from the division and move that decimal spot twice to get the percentage. And then with 1/6, that's going to be 0.16 repeating, or 0.166666, which would be approximately 16.7% if you round it off. And same with the Banzhaf power indices for players 3 and 4. And rounding them is totally fine, or answering them as fractions. It doesn't really matter to me. But when you're doing my math lab assignments and quizzes, just try to pay attention to the instructions because it should tell you what it wants and what form it wants. But in general, on a test, I don't really care. I do generally prefer percentages. And let's go ahead and wrap up this question by kind of talking about, okay, what is our conclusion, and what is this, what is this saying? But basically, after all is said and done, what we're calculating is the power level of each player. Player 1 has 50% power. Player 2, 3, and 4 have 16.7% of the power. So what we do is we get a better sense of who is, in this weighted voting system, who is really has the power and who, is contributing to that. Notice that there's no dummies or anything because everybody actually has power, which is a good thing, but we can kind of analyze more closely how do these numbers actually play into the weighted voting system. And it's not exactly what you might expect because player 1, who has just a couple more votes than the next highest, has half of the power, which is, not a majority, but pretty close. And the other three have actually equal power despite having the same number of votes. And if you really think about this situation very carefully, there is really no difference between 5, 4, and 3 because if we're thinking about in the context of player one doesn't really care who joins them, right? It could either be players 2, 3, or 4, and any of them join their side, they're going to win. But specifically, they don't. There's not really any differentiating factor between them. But in the context of the group of 3, they can technically win without player 1, which is why player 1 does not have veto power here, because they can win without him or her. But basically, anyways, the veto power is a little harder to tell because you can't use the percentages to do it. But that basically we've kind of figured out the question and answered the process of how, like, who's powerful and why, and kind of read between the lines. And we can quantify power in a way that's easier to understand, where we don't have to actually dig into all the numbers. We could even use a computer to tell us the answers, so we don't have to do all this math ourselves. But what I wanted what's important for you to know is how does this process actually work, and how could I calculate the Banzhaf power distribution on my own? And hopefully, as I've walked through these steps, it kind of makes sense why we're doing this, because really we're just trying to figure out all the ways people could come together and vote, and then figure out who's actually meaningful in those, which is the goal of finding the critical players. Now, in Chapter 2, Section 3, there's an entirely different method of finding power, which is called the Shapley-Shubik power distribution. Well, it's actually very, very similar. It just sort of uses one slightly different idea, and we'll get to that next lecture week on Monday. I'll do one more video of the next page. So on the next page, what I would usually do is give you this group activity as a class to work on in your groups. And in the same case, feel free to work on this one. But I will post the solutions in the next video just so you can check yourself. But again, before you watch that, try doing it on your own. And see if this is all making sense, because this is a fairly long set of steps. But if you follow the general idea, hopefully that made it a little bit easier.